Hi everybody, my name is Urška Vrabič Brodnjak. I'm coming from University of Ljubljana, Faculty of Natural Sciences and Engineering in Ljubljana, Slovenia. And today I will present you our research, which was done in collaboration with Dr. Dimitrina Todorova from University of Chemical Technology and Metallurgy in Sofia, Bulgaria. The name of the title of our presentation is Investigation of the Optical Properties of Chitosan and Rice Starch Blends as Fillers in Paper or as Film for Packaging Applications. Bio-based materials fall under the broad category of bioproducts and bio-based products, which includes materials, chemicals, energy derived from renewable biological resources. And in the last decade, interest in biodegradable polymers has been focused on packaging materials derived from these mentioned renewable resources. Such polymers can be chitosan, can be starch, some proteins, etc., which have already been produced and used in many applications, also in paper and packaging field. If we look on a structural level, paper can be regarded as a dense network of cellulose fibers consisting of cellulose microfibrils embedded in a matrix of lignin and hemicellulose. And because in our research we have made paper with blend fillers of chitosan and rice starch, which will be presented shortly, we used also, as mentioned, chitosan, which is a polymer consisted from a chemical structure which is very similar to the glucose unit of cellulose, but the amino group is located at the site of the hydroxyl group, as you can see also in this picture. The good and the positive properties of chitosan are that it acts as an antibacterial agent, has good water barrier properties, influences the water resistance of the paper if we use them as a paper coating, and which can be found in a number of different research sources. Namely, chitosan is very poor soluble in water. It achieves water resistance by combining its amino groups with hydroxyl groups of cellulose, and thereby forming strong hydrogen bonds prevents water from binding into the cellulose molecules. Because we used also rice starch, here are some details about it. This rice starch consists of glucose units, which is in contrast to cellulose and chitosan. They are linked together to form a more branched structure. Most types of starch contain two types of glucose polymers, a linear chain molecule, like amylase, and the branch polymer glucose, amylopectin. Well, in general, the positive cationic starch molecules are linked to negatively charged cellulose molecules, which can increase the strength of the paper. And of course, the use in paper should be handled with care, especially with higher quantities of the rice starch. Then the elasticity can be negatively affected. The properties of rice starch are also that it's insoluble in cold water and becomes water soluble when it's heated. In the manufacture of the paper, rice starch has been used as an additional component in films that form blends with other biopolymer. And if we look in general, rice starch is used as a binder of various coatings because the mechanical properties of the paper are, of course, increasing. When we started to determine the research focus, of course, we have found out that bio-based material fall under the broad category of bioproducts or bio-based products, which includes asset materials, chemicals, energy derived from renewable biological resources. The aim of the research was the preparation of paper which was made with blend fillers of chitosan and rye starch, and on the other hand, we also have made chitosan and rye starch films, which could be used as packaging material for a variety of applications. Namely, the aim was to improve the mechanical, moisture, and optical properties of chitosan rye starch, and on the other hand, the composite chitosan rye starch film using ultrasonic treatment, which was one of the procedures when preparing the coatings and when preparing the films. In this research paper, filler solutions with different amounts of chitosan and rye starch were applied into paper pulp suspension, and then the paper was produced as it will be described further and as it is described in our full paper. At the same time, chitosan and rye starch films as packaging material has been manufactured separately and properties were also determined. We have used, as said, chitosan, rye starch, glycerol, which was used as plasticizer, acetic acid we used at the production of chitosan, and we used in the pulp paper production modified cationic polyacrylamide. So, as said, we have prepared paper sheets and films. The preparation of paper sheets was followed with mixtures. We have prepared the paper with only pulp. We have used also then with the addition of retention additive, and then we have used different amounts of chitosan, retention additive, and rye starch, as you can see also here. So the paper suspensions were prepared using 6 combinations of pulp suspensions, biopolymers, and retention additive. The whole paper procedure of mixing pulp and other conditions when at this production, it's presented also in the full paper. The preparation of the film was less complex in comparison with paper pulp suspension and paper sheets. So at the films, we have used the rye starch dispersion, which was prepared by dissolving 2 grams of rye starch in distilled water, and we used also the glycerol as plasticizer, and then the solution was mixed at 85 degrees for 20 minutes, and then it was cooled down. The chitosan solution was prepared by dissolving 2 grams of chitosan in 100 milliliters of acetic acid, and glycerol was added as plasticizer. So the solution was then mixed at 19 degrees Celsius for 5 minutes until chitosan was not dispersed as whole, and then it was cooled to room temperature. When preparing the blend fillers, the rye starch chitosan film was prepared by mixing 100 milliliters of rye starch solution and 100 milliliters of chitosan solution, and then it was mixed for 5 minutes at room temperature. After the aspiration, the solutions were placed into ultrasound bath for 15 minutes. After this treatment, the mixers were poured onto petri dishes, spread thinly and evenly, and we dried them at 55 degrees Celsius for 10 hours. And after that, the films were peeled off these trays, these petri dishes, and cooled at room temperature. The methods that have been used when determining the properties of films and paper sheets were determination of basic properties like grammage, density, specific surface, thickness. Then we determined the color of the films, smoothness and air permeability only at papers. We have checked the surface with scanning electron microscope at films and papers. Then we tested also the printing quality and thermal aging of the papers. So, to evaluate the influence and effect of bio-based components onto paper, it was essential to establish and mix samples with the same grammage. Therefore, the paper sheets were prepared with the grammage of 80 grams per square meter. The beating degree of the pulped hardwood fibers, dimensions of the fibers, and addition of the fillers have influence on thickness of the paper, and this plays an important role at end usage, especially at printing papers like it was ours. As expected, you can see the thickness of the samples had mostly the same values. It's presented here at the table. Paper with only pulp, combination of softwood and hardwood fibers with no additives had the lowest thickness, and with the addition of the retention additive and fillers, the thickness at other all papers increased respectively. So the changes were also detected at specific surface and density, where a sample with only pulp and no additives had the highest density compared to other tested samples. Here is also the thickness and the color values. In this study, an ultrasonic treatment of the film solution was used in order to increase the solubility of the composition components, which influenced many film properties, like you will see further, like strength, elongation, and break, moisture, and color. If we look generally, color is an important factor of the appearance of packaging materials. So the total color difference, chroma and hue angle, were calculated from the color values. The untreated chitosan films were more colored than rye starch and blend film. It is known that chitosan has more yellowness compared to other tested samples in the research. All films also include plasticizer, which also affected the color. The hue angle was not significantly different among all sample films. So the results of calculated chroma showed that the untreated samples have more yellowness than the treated ones. Paper is highly porous material consisting of a matted fiber layer, and the additive could cause the variation of many properties such as smoothness and air permeability. The open surface of paper sheets decreased with increasing amounts of the above-mentioned polymers. Smoothness was better in samples with chitosan and rye starch. So the smoothness also improved with increasing amounts of biopolymers, as you can see here on the graph. As expected and shown in this figure, the air permeability was worst for paper containing only pulp. This is sample P. With the addition of biopolymers and retention additive, the structure of paper became more uniform and felt improved also the properties. So, in general, the best air permeability was achieved by paper with 7.5% of chitosan and rye starch, with only 1,186 milliliter per minute, which was measured. With scanning electron microscope, the evaluation of the distribution of chitosan and rye starch onto the paper sheets has been evaluated. You can see also here all the images. These micrographs show that the fillers covered the fibers and closed the pores, and at the same time the open areas in the base paper. The surface of the sample papers showed a smoother and more uniform surface for papers with fillers, compared to the sample without fillers, like only P and PR sample. A comparison between paper sheets with used fillers but different concentrations proved their effect, which is consistent with improved mechanical and water barrier properties. The absorption, thickness, moisture, and the roughness of the paper with fillers have a great influence on the properties of the chemical structure. If the fillers are unevenly distributed in the fiber paper composition, many properties can deteriorate afterwards, and this can also influence the printing process, like uneven printing image and mottling. At the scanning electron microscope micrographs of the films, you can see that the surface micrographs show smoother, more even surface on all treated films. It can be seen in figure 3a that the untreated chitosan film is less smooth and not as uniform as the ultrasonically treated film like 3b. The same trend can be seen in the figures 3c and 3d, where the micrographs show the rye starch, and figure 3 shows the untreated rye starch, which has more irregular surface than the chitosan film. Generally, the results have shown that the ultrasonic treatment caused homogeneity of the surface and is a good indicator for better structural, mechanical properties compared to the untreated films. And in general, the ultrasonic treatment can help to obtain a smoother and more homogeneous surface. With papers, color is important for the future finishing and printing processes. It determines the quality of the light reflected by the paper, which is described by hue, saturation, and darkness or lightness. Abrasion resistance was used to evaluate the resistance of printed surfaces to frictional abrasion. Failure or damage to the paper is related to substrate, ink adhesion, paper additives, thickness, and internal stress. It should be noted that there are several methods that can determine other aspects of imaging material degradation as a result of frictional contact with different surfaces under different conditions. Therefore, the application of specific methods depend on the end-user applications, such as the type of the packaging materials, coatings, barrier properties, requirement of the packaging paper, and so on. In our study, we have used the TEPI standard, which was used for determining the printing quality of our sample papers. As you can see on the picture on your left side, after 25 cycles, the papers were with chitosan and rice starch was included, achieved better quality according to other papers. Before rubbing, the highest optical density had paper with 5% of chitosan and 7.5% of chitosan and rice starch. The highest concentration of the filler, the most stable color resistant, was after rubbing of 50 cycles. As expected, fillers increased color stability compared to the paper sheet, where the fillers were not used. From this part, it can be concluded that rice starch and chitosan had great influence on more stable and durable printing properties. On the picture on your right side, you can see also the graph, which shows the results of the optical properties of the investigated paper samples with and without addition of different amount of our biopolymers, and we also tested the thermal aging, which was proceeded. So the investigation on the optical properties of the obtained paper samples during accelerated thermal aging showed that the aging of the sample papers with addition of chitosan and chitosan rice starch blends have the same behavior through the 72 hours of aging. The largest change was observed in the first studied parameter, this is the whiteness, which after the end of the accelerated thermal aging has described by approximately 50% has decreased. If we go to the conclusions, we can see that certain fillers in the paper can make their functionality and the end use of the paper possible. From previous and our research, it has been proven that fillers can offer many advantages, such as improved printing, surface, and many barrier properties. For packaging paper, print quality is an important factor among all other properties. Research has shown that paper samples with these fillers improved abrasion resistance, and no major color difference occurred compared to paper with no fillers. The aging on paper with the addition of chitosan and blends with the rice starch has shown that they show the same behavior over 72 hours of aging. So further, to improve the barrier properties of packaging paper, this type of bio-based paper could be associated with additional, and as mentioned, it could be associated with additional additives and also concentrations of polymers presented in our study. Thank you for your attention.